Hello and welcome to another one of these ADD videos. Today we're going to be discussing quadratic functions. You have probably seen quadratic functions already as this parabolic function many times in your math classes. And you know that the min or the maximum point is referred to as the vertex, and the order pair is h comma k. And if you are looking at it in standard form, we have this h comma k. Notice the opposite of the h, and k stays the same. And if a is greater than 0, it opens upwards, smile, some people say. And if it is less than 0, it opens downwards. Okay, just a few trends of the quadratic function. You might see the function not in standard form, but in general form. Okay. And the general form looks like that. And if you're asked to find the vertex in that manner, you have to use this formula, in which the x value will be taking, oops, sometimes my highlighter does that. I'm not sure why. So we'll underline it so it doesn't do that again. So we have minus b over 2a and f of minus b over 2a. Okay? So what that means is take your b, opposite of it, divided by 2 times a, and then take that answer and plug it in everywhere you see an x in your function. Okay, so there's x there, there's x there, and that'll give you the y value. Anytime you have an x value, to get the y value, plug it into your function for x. Alright, so that's the other way to find the vertex. Now there's an interesting little axis of symmetry here that allows you to basically, oh, now I'm allowed to highlight again. That's weird. Sometimes it doesn't work. This axis of symmetry basically is a vertical line that goes through the x value of the vertex. In this case, since the vertex is 0, 0, it would be x equals 0. This h value would be 0. But it's basically a mirror image. Basically states that if I have a point that's 1 unit up and to the right of my vertex, up and to the right, the axis of symmetry says that up and to the left 1 unit should also be a point. Okay, allows you to use the concept of reflecting. So then here is 2 comma 4 if I were to plug in the x squared, right? So what does the axis of symmetry say? Well, there should be one at negative 2 comma 4. All right, and basically allows you to graph it a little bit quicker if you were doing plotting your points. Now, if we're looking at the quadratic formula, that's a way to find your roots if you're talking about the zeros, the x-intercepts, whatever you want to call them. And you just plug in, given that original general formula right there, a x squared plus bx plus c, you take minus b plus or minus b squared minus 4ac square rooted over 2a. This b squared minus 4ac is referred to as the discriminant. And the discriminant basically can tell you what kind of solutions you have. If it's equal to 0, then all you have left is the minus b over 2a. And that's just one real solution. But if it's greater than 0, it's 2 real solutions, and less than 0, it's 2 imaginary solutions. If you remember, the square root of a negative number gives you a imaginary solution with complex numbers, i's. All right? Sometimes you might be asked to go from a general form to a standard form. You got to complete the square to do that. It's easier to just see it done, but the basic scenario, you're going to have 2 scenarios in which one, this a right here will equal 1, and then the other scenario you'll actually have a number there, whatever the number may be. So if it's equal to 1, it's pretty straightforward. All you do is you take half of that middle term b and you square it, and when you square that answer, you also add whatever you get to create what's called a perfect trinomial square. Those of you that have watched my videos should have seen the special cases of factoring and recognize the term PTS, or perfect trinomial square. And what you're going to do is you're going to create something in which you can go from a trinomial to a binomial pretty easily. That's the whole concept of completing the square. And it's going to end up looking like something x plus or minus a number squared, and then whatever that number you add there, if it's on the same side of the equal sign, then what you do is you do the opposite. You subtract that number, and if it's on the opposite side of the equal sign, you add that number, okay, whatever that number is. And it'll make more sense once you see the examples, so make sure you check out the example video. The only difference is if a is not equal to 1, first step is you're going to have to factor out that a term, okay, and use hat over factor from greatest common factor, factoring out, and then you do all the steps you did when a did equal 1, but at the very end when you add the number or subtract the number, depending on if you're the same side or the opposite side of the equal sign, then you got to multiply that number by a. That's the only difference, okay? So again, check out the example videos. There should be an example video on graphing these quadratics. There should be an example video on quadratic formula, and then finding the vertex, okay? Well, actually, vertex would be part of graphing, so completing the square would be the other video. I hope I've clarified any confusion that you might have on quadratic functions. Make sure you practice a few of these on your own to really get the hang of it. Thank you and have a nice day.